Sorry, Ross, we might have to redo this whole thing if I can get this to go live.
That's okay. Then I get to absorb it even more. I never got a computer science degree. So some of this.
All right. All right, guys, I think we are live now, so 1 second. We're going to actually start the presentation over. It was saying I was live on YouTube, and I went through more than half of it. So we're gonna start this over. All right, guys. Sorry about that. All right. Well, again, welcome to Flutter Atlanta. I'm not going to give you guys the reminder, but again, we're using the mics in the ceiling. My name is Emmett Dean. I'm an engineering manager over the Flutter team here at Black Airplane. I have a background in native Android and iOS development, and I've been using Flutter for over 3 years. We've published over 12 Flutter apps, and we have several more in progress, and I love Flutter so much that I'm using it in my own projects. I want to give a quick shout out to Black Airplane for the food and beer. Black Airplane is a leading development agency in the Southeast, and we have a special team of people that produce top quality work here, and we're capable of building pretty much anything. Before we get started, I do have one announcement. Upcoming is Flutter Forward on January 25th. This is when Flutter is going to announce all the new different features that they're coming out with and all the different investments they've been doing in the framework. They're doing it live from Kenya, which is pretty exciting because one of Flutter's big activations is to try and bring this framework to a bunch of places that wouldn't have normally had access in the past. So today we're going to be talking about Flutter Architecture. This is going to be a mix of the architecture that we use and also from another big player in the space called Very Good Ventures that also uses a very similar architecture to us. So let's go ahead and dive in. So first off, what is a software architecture? It is the logical way that we organize our projects, and it's very important for you to invest in this at the beginning of a project to make sure that you don't overcomplicate things that don't need to be, and make sure you're not stepping over yourself in the future with having messy code. So before we get started, let's talk about the single responsibility principle. This comes from object-oriented programming, and it's the idea that each class or component should have one unique purpose. This separates the components and helps simplify testing, and separate functionality makes it easier to maintain because it's not going to be tangled in with a whole bunch of different code. So let's dive into our architecture. It has 3 main layers, and these are typically what you would call the layers, but sometimes the application layer is also just called the presentation layer. So first we have the data layer, which is typically meant for interacting with an API or data source. Then you have the domain layer, which is used for manipulating the provided data. And then the application layer, which is meant for presenting the data and gathering user input. And as you can see here with the Very Good Ventures graphic, the application layer is actually split into a presentation and a business logic layer. In practice, these files typically live next to each other. That's why they don't actually have 4 full layers here. The block files will typically live right next to your presentation files as well. But it's important to note that we have the business logic separated out of the UI, which we'll talk about more in just a second. So first, let's talk about the data layer. So the data layer typically is going to be where your data sources live, and these are classes that allow us to interact with needed databases and APIs. These are going to be things like Firebase helper classes, API helpers, it could be a GraphQL client if you're using GraphQL, local storage, and also helpers for your authentication system. Next, we'll talk about the domain layer. Domain layers are typically where your models and services live. Models are strictly typed classes that represent objects used in our applications. These are going to be things like users, reviews, and etc. Hey guys, thanks for joining. And then the domain layer will also have services in it. So services are typically a layer on top of the data sources in the data layer that allows you an easier way to interact with your data. So these are going to be things like you may have a general Firestore class as a data source in your data layer, but maybe I have a user service in my domain layer that allows me to just simply call userservice.read and then pass it an ID. It'll pass me back a user object. So this level of abstraction makes it extremely simple to use in your business logic layer. The application layer has everything to do with presentation as well as the business logic. So this is going to contain things like routes, which is where you keep all of your different named routing, which can be very important if you're building a web app with Flutter. It's going to have your individual components, which are UI elements that are going to be given their own class so they can be reusable, as well as layouts, which may be a collection of components that you're going to be using in multiple places, perhaps like a dashboard layout or a navigation layout, and then complete screens as well, which is going to be the UI for each individual screen of your application. The business logic is going to be separated out, but it's going to live in this layer as well, and it will be the logic behind your app and specifically separated from the UI components. Typically, this is going to be into whatever state management library you choose for your project. So let's talk about state management. And most of these examples we're going to reference Block, which is still the recommended state management for Flutter from Google. And this is an event-based state management system. So Block has three different parts. The first is going to be the events, which these are going to be the actions supported by the component or screen. For example, if we were building a login screen, an event may be to trigger the login. And the qubit or block is going to be the portion that actually determines, based on this event, we need to do these actions and return a state. And a state is going to be what's going to be shown on the screen right now. So that could be a success state, a failure state, or the need for more user input. There are several different options for state management, and it's one of the biggest debates in the Flutter community right now. Some other ones you could check out are RiverPod, GetX, as well as Provider. As long as you pick one and stick with it, they all do state management just fine. So pick one for your architecture and make sure to stick with the same one. Very important, avoid mixed responsibilities. Avoid adding data fetching or business logic into your presentation layer like below. Use your state management system to handle that instead. So Flutter out of the box gave us all of these nice widgets, which are great for simple sample projects, but they're actually going to bite you if you use them in a big application. Part of this reason is, if you were using this stream builder here to render out your UI, and all of a sudden you were starting to get errors, you might think that it's going to be an error in your user interface, but really it's probably an error in the data portion of the app. So by separating this, it's going to untangle your UI and create more isolation between the layers, which is going to make it easier for you to debug your applications. Build with reusability in mind. The separation of layers should allow the layers to work independently. This will allow you to reuse these layers in other apps or even publish them as packages. So if you had a lot of UI components from one app that you needed to use in another, you could create a package just out of that presentation layer and reuse it. Or if you were going to use a specific Firebase backend structure and you built out a really nice data layer for it, you could actually publish that as a package and reuse it in your other apps as well. Use the right amount of abstraction. There's no need to create needless wrappers for packages that are already consolidating the work for you. But you should create wrappers if there's complex functions or processing needed from the data. For example, if you are going to access an API, you should create a wrapper for this. You don't want to have to use your HTTP client every time you need to make a call. You should simplify it by doing most of your HTTP client configuration in this data layer and then build services on top of this API layer. So what are some advantages of this architecture? The strict types and requirements force all developers to follow the architecture, which results in consistent new code from all developers. The separation of layers allows us to completely change UI or completely change data sources, for example, from a Firebase backend to a Laravel backend, without having to dig through any extra code in the domain or presentation layer. Familiarity between projects for developers consistently working on Flutter projects can be a huge advantage if you have a team working on multiple apps at the same time and they're all structured the exact same way. You'll also experience increased reusability of code between projects when you start having this kind of organization pattern. It also allows for separation of work. For example, one developer could work on the UI layer completely uninterrupted by another one who's implementing the services or the backend. What are some big company tactics that are going to be available for all projects? So these are some tools that we use on all of our Flutter projects here, which are going to be your CICD, your standard code styles, increased testing, and also decreasing the size of feature branches into smaller, more specific tasks. So the first one we're going to talk about is CICD. And for CICD, this is a tool that we use called CodeMagic, which was a purpose-built CICD tool for Flutter. They're a great company, and their CEO actually, when we did a specific talk on CodeMagic, sent a video answering a whole bunch of questions that we had from them. So they're also really plugged into the community, which is great to see. This allows for automatic testing of merge requests or pull requests, and it adds the outcome of the test of the merge request directly into GitHub or GitLab. It also allows for automatic builds. So building an app for both Android and iOS will take an hour of dev time if everything goes right the first time. So there's a huge savings of dev time, and it allows for more regular builds for incremental QA testing and deliverables. And a quote from Jess Humboldt, "If it hurts, do it more often and bring the pain forward." By running things like nightly builds, you can avoid a lot of the pain around making those release builds for your application. It also has support for automatic deployment with manual publishing still being required. It can automatically upload your builds to both the App Store, Google Play, and we use Firebase app distribution for our beta testing here. So it can automatically upload those, and then whenever you sign into your console, you just select the build you want to publish, and it's a lot quicker process from there. So I highly recommend using CodeMagic. It's also very affordable for personal projects. There's no reason you shouldn't be using a tool like this. Next, we're going to talk about Flutter Lens. So right out of the box, there's a package called Flutter Lens. I believe it's also included in any new projects you set up. And it's the recommended set of linting rules from the Flutter team. So this is going to force clean and consistent code styles even further than the architecture. So this is really useful to make sure things are done the expected way. And you can also use a tool like CodeMagic to enforce that all the developers are adhering to the Flutter Lens that you're set up. Also, increased testing. So Flutter supports 3 different types of testing, which are unit, widget, or component, and then also integration testing. With the separation of the layers that we talked about before, it's going to be way simpler to make unit and component tests. So these are going to be tests that test a specific function, method, or class. So if you were to have a Firestore helper in your data layer, you could use some sort of mocking service to mock Firestore and make sure that your data layer is actually working as you expect it to. And then for widget and component tests, these are going to be testing your UI to make sure for all the different states that you may have set up with block, it's displaying exactly what you would expect for the given states. And then integration tests are a little bit harder to write or also to enforce because they need to run on a physical device. So this is as close as you could get to a real user tapping through your application. You're basically going to say, tap this button, enter this input here, tap this button. So you can really do amazing things with testing an entire flow, but it's going to take a lot of time and also a lot of resources to test in any automated way. And then also just smaller feature branches. It's going to be easier for your code review if you're working in a team. You're less likely to have merge conflicts, and it works better in conjunction with the continuous integration testing that we were talking about. Last, do we have any questions? And I also put up that graphic of the architecture we were talking about in case you need to reference it. If you're online, just throw your questions in the chat. Yeah.
I definitely have, looks like 2 questions. One was apropos of this diagram. Could you talk any about how these layers map to folders, files, and projects?
Yep. So in our actual application, we really do just have a folder called data, domain, and then application or presentation. And then inside of the application layer, we'll break these out into modules. So these are what's going to be our folders. So the login, the weather forecast, or the settings, we'll have a folder for each of those things. In the domain layer, we typically have a folder for models, and then a folder for services, and then we don't need any more folders there. And then the data layer is typically so simple for us, where you normally have a Firebase class or an API class, and the data layer is very simple, so it's just going to be that one folder. Does that help?
Yeah, it does. It does. And then I'm, thinking about my own project and how, do I want to make a change like that? That's really interesting.
Any other questions?
So what are the popular Flutter test libraries?
So when we write Flutter tests, we just use the out-of-the-box test system. So again, that they have just the UI, the component, and the integration tests. I have seen some packages for golden tests, which are making sure it looks exact to screenshots from my understanding, if that's extremely important. But typically just out-of-the-box testing libraries are great. You may have to get some Makito type libraries to help you mock different resources, but that should be it.
Okay. Oh, so Makito is used in Flutter. Flutter. Okay.
Yep.
Yeah, I was kind of trying to figure out what ones were used. Thank you.
And another one, which is, and maybe this requires going into too much detail, but like, you had that stream builder example as a negative example. And I was like, oh, I got those in my thing. But I don't have in my head what the alternative looks like. And yeah.
So if you were using something like block here, you're going to have what's called a block builder. And the block builder is going to give you all of the different states. So it's going to give you a builder function that's kind of like this builder function, but instead of a snapshot, it's going to give you a state. And then in this logic, it's going to be basically if the state is equal to loading, return a loading indicator. If it's equal to like a show state, show the login input. If it's equal to a success state, show success. So that's the difference. And then you don't have to put anything related to your data.
Fully hidden. Any rhyme or reason for why those states and any of that are completely abstracted away into a different file.
Yeah.
Or files. Got it. Okay.
So that'll just make this component more reusable. Now it is still in that case fairly closely tied to the business logic, because if you were to change the state in the business logic or the set of states, then you will have to change your components to be able to handle that. But that's kind of why they live next to each other all under that application layer versus being fully separated out.
Is that a separate package? Like,
so
forgive my ignorance. I have never heard of block.
yeah,
So
we can look at this real quick. There's a lot of different types of block now. I highly just recommend starting with Flutter block. This is going to give you some of those nice widgets. So we go down to like their block builder example. So like here's the example of a block builder where it gives you the different states out. You can determine when it builds and stuff like that. There's a simpler version of this called qubit, which it will also talk about here, which is like a qubit's going to be related to a single value versus having a whole bunch of different states and events. But yeah, this is one of the more popular, more popular state managements right now.
okay, thank you.
Any other questions? I don't think I have any coming in online. Meanwhile, I'm chilling with Provider. Yep, Provider was originally Flutter's recommended, and then a whole bunch of other state management libraries popped up. And from what I've seen, Block is still the most popular for enterprise applications. But like I said earlier, pick a state management, use what works for you. At the end of the day, they all manage state, and they all work. So pick whichever one you like, you're most comfortable with. But I would recommend learning Block at some point because the industry seems to be most comfortable with it for enterprise applications. All right, any other question? Next time we're going to be talking about MLKit in Flutter. MLKit is a Google service, so this is going to be doing some cool things. We'll probably talk about pose detection and some other things actually directly in your Flutter app. So come for that one. I'll be talking on that early February.
Is that machine learning?
Yep.
Oh, yeah.
Okay.
Awesome. Thank you, everybody, tuning in online. We will see you next time. Man, pretty much did that whole thing.